All right, this is notes on section 10.3, Parametric Equations and Calculus. We're going to do three things. We're going to find the slope of a tangent line, find the arc length, and the area of a surface. You don't have to write these down in your notes. You should write everything else down though. These are all when you were dealing with parametric equations. All of these are things that we have already done at some point. We're just going to do them in terms of parametric equations, where instead of giving one equation, we have two equations, one for x and one for y, with a parameter t or theta. So the first theorem you need to write down is theorem 10.7. You probably want to pause at this point and just copy this down. I'm just going to run through it real quickly. So the parametric form of the derivative, f of x, if x equals a function with t and y is a function with t, then the slope or derivative, the first derivative, dy over dx, is the derivative of the y part divided by the derivative of the x part. And you just can't have the derivative of the x equals 0. The first derivative finds extrema, maximums, minimums, increasing and decreasing. That's just a review. The second derivative, to find the second derivative, I just use this formula again. The second derivative, d2y over dx2, is the derivative of the derivative. Okay, so I'm going to take the derivative of the derivative on top divided by dx over dt. And the second derivative finds inflection points, and you can discuss concave up and down. The sign of the second derivative tells you concave up or down. Alright, so now we're going to look at several examples using the parametric form of the derivative, and we'll come back to these other theorems at the end. Okay, so example 1, find the derivative and second derivative, then find the slope and concavity at the given value of the parameter. So I want to find I want to find dy over dx, not dx over dt. I want to find dy over dx and first and second derivative. Okay, so the first derivative is equal to the derivative of the y part divided by the derivative of the x part. And the reason these are dy over dt because both of these have t as the variable. So the derivative of the y part is 2. The derivative of the x part is 2t plus 3. There's my derivative. Okay, so now I need to find the value of this when t equals 0. So dy over dx then equals 2/3. Alright, now I need to find d2y over dx2. And that means I'm going to take the derivative of the derivative divided by dx over dt. So the derivative of the derivative on top, so the derivative was this. Okay, so in order to do this, the dy over dx, I'm going to have to use the quotient rule. So the bottom times the derivative of the top is going to give me 0. Minus the top times the derivative of the bottom gives me -4 over the bottom squared. On the bottom, I have dx over dt, which is just 2t plus 3. Simplify that. Basically, I just multiply by the reciprocal of this, which will give me -4 over 2t plus 3 cubed. And then that value when t equals 0 is going to be -4 over 9. And that's the second derivative at 0. So you've got, there's your second derivative, there's your first derivative, and there are the different values. Alright, example 2. We want to graph the curve. We want to find dx over dt, dy over dt, or dy over dx. So we want to, basically we want to find dy over dx at the given value of the parameter. And we want to find then an equation of the tangent line at the parameter, and then we want to graph the tangent line. Now the graphing things, I'm going to use my calculator. Okay, I'm going to use my calculator to graph these things. So I'm going to turn it on, and I'm going to hit y equals, and I'm going to graph 4 cosine of theta, and then I'm going to graph 3 sine of theta x, and I'm just going to hit graph and see what happens. Okay, this is not what we want. What we actually want is we want to combine these two together. So we are going to have to do something in order to actually graph this on the graphing calculator, and that would be, well, we could write it in rectangular form. So rectangular form would mean the cosine of theta is equal to x over 4, and the sine of theta is equal to y over 3. And so if I use the sine squared cosine squared, I end up with x squared over 16 plus y squared over 9 equals 1. So now I have the challenge of graphing this function in the graphing calculator, which, you know, we can do it a couple of different ways. We can get y by itself. Okay, so I subtract that. I'm going to multiply everything by 9, and then I'm going to take the square root. And I would have to type in both the positive and the negative in order to get the correct equation. So what I can do, I can go to my y equals. I'm going to clear these equations out. And I'm going to go up and I'm going to type in second square root, and I'm going to type 9 parentheses 1 minus x squared divided by 16, and enter, and then I'm just going to do that same thing with a negative sign in front of it. And then I'm going to graph both of those, and I should see the actual correct shape here, which is an ellipse, which hopefully you could have just graphed this ellipse without going to your graphing calculator. You should have known the center's at 0, 0. You go 4 away in the x direction, 4 away, and 3 away in the y direction. And that's what it looks like. Okay, so now we need to find dx over dt. So there's our graph. There's part 1. Dx over dt, this is going to be part 2. Dx over dt, well, that is derivative of cosine is negative sine, so negative 4 sine of theta. And at 3 pi over 4, well, dx over dt equals, let's see, the sine of negative 4 sine of 3 pi over 4. Well, 3 pi over 4, 3/4 pi is over here, cosine comma sine. Let's see, that's going to be a positive radical 2 over 2. So dx over dt equals negative 4 times radical 2 over 2, so negative 2 radical 2. All right, now we want to find dy over dt. So the derivative of y, and actually these are d thetas if we want to be real specific instead of dt's. So this would be 3 cosine of theta. And so here's one answer up here. And then at 3 pi over 4, I want to plug 3 pi over 4 in. Okay, and cosine of 3 pi over 4 is negative radical 2 over 2, so this is negative 3 radical 2 over 2. Okay, finally dy over dx, and we could have just found both of these, divided them, and then plugged it in. So dy over dx means, well, here's dy over d theta, that's 3 cosine of theta, divided by negative 4 sine of theta, those are our two derivatives. And at 3 pi over 4, well, we've already worked both of the top and the bottom out, so we worked the bottom out here. That's negative 3 radical 2 over 2. And this one is negative 2 radical 2. So if I'm going to divide these two, I'm going to multiply by the reciprocal of this, so negative 3 radical 2 over 2 times negative 1 over 2 radical 2. The radical 2's cancel. I get 3 over 4 on top. So I could have just jumped ahead and found this and then worked it out right there. I didn't have to do those two parts. Okay, that's step 2. Step 3, find the equation of the tangent line. Now a tangent line at the point 3, when theta is 3 pi over 4, I know that the x value is, and the y value is. So when theta is 3 pi over 4 on my function, then x is 4 times the cosine of 3 pi over 4. The cosine of 3 pi over 4 is negative radical 2 over 2, so that'll be negative 2 radical 2. The y value when theta is 3 pi over 4 the sine of 3 pi over 4 is positive radical 2 over 2, so y is 3 radical 2 over 2. Okay, so why did I need this for writing the equation of the tangent line? The equation of the tangent line is y minus y equals m times x minus x. So if I'm going to write that equation of the tangent line, I need to know the slope. Well, the slope is the derivative, so m is the derivative at 3 pi over 4, which we've actually already found, which is 3/4. And x1 and y1, the y1 and the x1 are an ordered pair. x1 comma y1 is an ordered pair, which we have right here. So all I have to do to write my tangent line equation is take y minus 3 radical 2 over 2. Your slope is 3/4. X minus a negative makes it plus 2 radical 2. Which you can simplify. You could distribute this and add this over, so that would be 3/4 x. And then distribute this, that would be plus, let's see, 3 radical 2 over 2 plus another 3 radical 2 over 2 gives me my tangent line is y equals 3/4 x plus, well, that just gives me 3 radical 2. So there's my tangent line. If I go and try to graph that tangent line on my graph that I already made, let me fold this for just a minute so you can see them both in the same thing. So I've got my graph now, my graph and my tangent line. The y-intercept is at 3 radical 2, 3 radical 2, 3 radical 2 is approximately 4.24, so it's like up here. That's where it hits, and the slope is down 3, you could go down 3, backwards 4, up 3, forwards 4, but it's the same as down 3, backwards 4. Another way you could do it is go back to your y equals. You have these graphed. Type in a third graph, which is 0.75x, 3/4 is 0.75, and then plus 3 radical 2, and hit graph now, and now you'll get the tangent line graphed in there. Looks like our picture. So utilize your graphing calculator when you can on these to do all those parts. We'll have a second video for the rest of this, so be sure to finish taking the notes on the last 4 examples. Thanks.